Once again, welcome to my YouTube channel, Pearson Edexcel International Maths by Mr. Kamotho. And of course, let's work together. We are explaining Edexcel Pure Mathematics 1 all the way to 4. And of course, International GCSE and Statistics and Mechanics moving forward. And in this video, I would want to continue explaining about the chain rule. And again, I continue to refer that dy dx is given by dy du times du dx, where y is a function of u and x is a function, and u is a function of x. So we have had chain rule before, and therefore this is not anything new. But sometimes you will get expressions which are in terms of x is equals to the function of y. How do you deal with such a function? You realize that the best you can do, you can only have dx dy, which is of course the derivative of x in terms of the derivative of x in terms of y. And in this case, we may look at this being equals to this, but this is not true because our function is not in terms of y. So that does not apply there. And we may want to talk of how then do we get dy dx? Following this, dy dx is of course 1 over dx dy, whereby we divide by a fraction, and the moment we divide by a fraction, it means we multiply by the reciprocal, because this is of course 1 over 1, which is the numerator, times the reciprocal of the divisor, dy dx, which is dy dx. So yes, this arrangement is very important at this level of the topic, and especially when we are given functions that are functions of y, or x is the subject of the formula. So, and this one is going to be explained further in example 9 of P3, Pure Mathematics 3, page 130. It's a short example, and we just have to understand it. Find dy dx at the point, find dy dx at the point 2, 1, on the curve, with equation y cubed plus y is equals to x. It goes without saying this is a function or an equation where x is the subject of the formula. And let's just write it clearly here that x is equals to y cubed plus y. And the best we can do here is simply dx dy, the differential of x with respect to y, which is easily 3y raised to power 2 plus 1. But we needed dy dx, and according to what we have understood here, dy dx in such a situation is 1 over the dx dy, and this one takes us to dy dx is 1 over 3y squared plus 1. And we are also told that this one is a function, and when we sketch it, we are talking about a certain point, 2, 1. At 2, 1, of course, you can see y is equals to 1. So if we substitute y being equals to 1, then it follows that dy dx is 1 over 3, then 1 squared plus 1, which is easily 1 over 3 plus 1, which is a quarter. And that is just like what we have been able to express. Dy dx is equals to 1 over 4, which is a quarter. And yes, I hope you followed. It's a different format of chain rule whereby we've been able to employ dy dx is equals to 1 over dx dy in case we are given a function that is already giving us x as the subject of the formula. There's nothing wrong with differentiating x with respect to y, and of course make this arrangement to get your dy dx.